Hello children. Today in this session we are going to discuss about what is specific heat and what are the units of specific heat and what are the applications of specific heat. Before going to know about specific heat, I want to show you some pictures and you have to observe those pictures. Then I will ask you some questions regarding those pictures. Let us assume that there are some ice cubes in your palm. How you may feel? You may feel cool. Why you are feeling cool? Because the heat is transferring from your body to the ice cubes. Here the ice cubes are the cold body and your palm is the hot body. That means the heat is transferring from the hot body to the cold body. Now we shall conclude that heat transfers from a hot body to the cold body. Let us see another example. See the second picture. Let us assume that you touched your hot lunch box. What you may feel? It is so hot. Why you are feeling like that? Because the heat is transferring from the hot lunch box to your body. That means here the hot body is your lunch box and the cold body is your body. Okay, now we shall conclude that heat transfers from a hot body to the cold body. Children, let us take an example. Let us take two bodies. The first body is at 0 degrees centigrade and the second body is at 100 degrees centigrade, which are having the same mass. When these two bodies are kept in contact, what will happen? The heat transfers from hot body to the cold body. That means from the body which is at 0 degrees centigrade to the body which is at 100 degrees centigrade. How much extent the heat transfer will be there? Until a common temperature attains. That means here in this example, if you see, both the two bodies are attained to 50 degrees centigrade. Then the heat transfers will be stopped. So in this condition, we shall treat them as they are in thermal equilibrium. In the examination, they will ask you if a body A is in thermal equilibrium with B, if A is at 45 degrees centigrade, what is the temperature of the B? Then you have to answer that because AB are in thermal equilibrium, since the temperature of A is 45 degrees, the temperature of B is also 45 degrees centigrade. Here the heat is transferring from hot body to the cold body. That means we can formulate a formula, principle of calorimetry. What is the principle of calorimetry? Heat lost by the hot body is equal to heat gained by the cold body. Let us explain the principle of calorimetry using an example. Let us take two test tubes. In the first test tube, there is a liquid of mass m1 which is at a temperature T1. And let us take a second test tube with liquid m2 which is at a temperature T2. Now we are mixing these two liquids. What is the total mass? m1 plus m2. What will be the common temperature attained on mixing these two liquids? We shall calculate the common temperature by using a formula T is equal to m1 T1 plus m2 T2 by m1 plus m2. Now we shall take a problem and we shall do the solution also. In the examination they will ask you this one. What would be the final temperature of 50 grams of water at 20 degrees centigrade temperature and water at 50 grams and 40 degrees temperature? Let us consider two test tubes. In the first test tube, M1 is equal to 50 grams and the temperature of the liquid, that is water, is 20 degrees centigrade. That is M1 is equal to 50 grams and T1 is equal to 20 degrees centigrade. And let us consider the second test tube. The mass of the water present in the test tube is M2 is equal to 50 grams and the temperature of the liquid which is present in the test tube is T2 is equal to 40 degrees centigrade. Now we have to calculate the common temperature. Just write down the formula. T is equal to M1 T1 plus M2 T2 by M1 plus M2. You have to substitute the values 50 into 20 plus 50 into 40 by 50 plus 50. That means M1 T1 and M2 T2 in the given formula, and you have to calculate the common temperature. Okay. Now let us discuss about what is specific heat. Just I will show you some pictures. There is a aluminum sheet and there is a iron rod also, both having 50 grams of mass and both are at 30 degrees centigrade temperature. Now I want to increase the temperature of aluminum and iron also to 31 degrees centigrade. That means I want to rise the temperature 30 degrees to 31 degrees centigrade. That means I am supplying the heat for the increase of 1 degree centigrade. The minimum energy required to rise 1 degree centigrade of temperature of a unit mass of substance is called the specific heat. Now just see, the specific heat of aluminum in CGS units is 0.21 calories per gram degree centigrade and for iron 0.15 calories per gram degree centigrade. In SI system, the specific heat of aluminum is 882 joules per kg Kelvin and for iron 483 joules per kg Kelvin. The calories per gram degree centigrade is the unit of specific heat in CGS units and joules per kg Kelvin is the unit of specific heat in SI system. In the examination they will ask you what are the units of specific heat in SI system or in CGS system, like that. You have to answer in CGS system calories per gram degree centigrade and in SI system joules per kg Kelvin. Let us define what is specific heat. The amount of heat required to rise the temperature of unit mass of the substance by 1 unit is called the specific heat. Now we shall see what are the specific heat values for various substances. Just see the table. For ice 0.5 calories per gram degree centigrade and for water 1 calorie per gram degree centigrade. That means high specific heat means these substances will absorb more heat for the temperature rise. Low specific heat substances means they absorb less amount of heat for temperature rise. In the academic standard, 4th academic standard information skills, they will give you a table like this and they will ask you like that. What is the relation between the temperature rise and the specific heat values? Now we shall discuss why these substances are having different specific heat values. Because if we are supplying heat those substances, the heat energy distributes into different types of energy for the increase of linear kinetic energy, rotational energy and also for the potential energy also. But for those substances, the heat energy supplied is utilized maximum for the increase of linear kinetic energy. In those substances, the temperature rise will be very fast, so they will have low specific heat values. Now let us discuss why the specific heat is different for different substances. The heat energy given to the system will be shared by molecules among various forms of energy like linear kinetic energy, rotational energy, vibrational energy, potential energy. In the given picture also you can observe the various types of motions also. But in those substances, heat is utilized for the increase of linear kinetic energy. In those substances only the specific heat values will be low. Okay, now let us discuss about what are the applications of specific heat. Before learning about the applications of specific heat, you have to remember two important points. Low specific heat. The objects having low specific heat gains or loses heat quickly. Low specific heat materials will be heated up and cools down very quickly. They will have a faster temperature increase and also they will have a faster temperature decrease also. They are very sensitive to temperature changes. Okay, now we shall discuss about high specific heat. The objects having high specific heat gains or loses heat very slowly. That means they heats up and cools down at a slower rate and they requires more heat to rise its temperature. They can absorb a great amount of heat. First of all, you have to note down the points. Low specific heat means object gains or loses heat quickly. High specific heat means object gains or loses heat very slowly. Now, let us see the applications of specific heat. Let us see the designing of a cooking pot. The body of the cooking pot is made up of with aluminum, which is having low specific heat. Handle of the cooking pot is made up of with plastic, which is having high specific heat. And the base of the cooking pot is made up of with copper, which is having low specific heat. Because the base and body are made up of with low specific heat, the temperature rises rapidly and very quickly, thereby we can save the fuel. The handle, it must act as an insulator. For that purpose only we are manufacturing the handles with high specific heat. Now let us see the second application. When we are eating a samosa, the curry inside the samosa is very hot when compared to the outer part of the samosa. The curry inside the samosa is having high specific heat and the outer part of the samosa will have a low specific heat. That means low specific heat means the outer part will lose the heat energy very quickly. So it will cool down when compared to the curry inside the samosa. But the curry which is inside the samosa is having high specific heat, so it loses the heat very slowly. So it is very hot compared to the outer part. Now let us see the third application. A watermelon is kept outside the freeze for a long time, even though it will be very cool. Why it is happening? Because there will be a larger amount of water in a watermelon. What is the property of water? The specific heat of water is very high. So, due to the higher specific heat of water, water will lose the heat energy very slowly. So, the watermelon is so cool after a long time also when it is kept outside the freeze. Let us discuss about the fourth application, the next application, cooling system of a car engine. In a car engine, we are using water as a coolant. Because of the higher specific heat value of the water, Even though it absorbs more amount of heat, the increment in the temperature will be less. So we are using the water as the coolant in the car engine. Let us see another application. The houses which are covered with grass are so cool in summer. Why? Because the grass will have a higher specific heat. So they absorb heat very slowly. So thereby the houses which are covered with grass are so cool. If you observe the concrete buildings, they are very hot in summer because the materials used for the construction of the concrete buildings, they will have low specific heat, they will gain the temperature very rapidly, so they are very hot during summer. Let us see another application of specific heat, sea breeze, sea wind towards land. Land has low specific heat than water present in the sea. Due to this, faster increase in temperature will take place on land. So, land is warmer than sea. Air above the land is heated up and rises. Cooler air from the sea moves towards the land as sea breeze. Okay, now let us consider another example, land breeze. At night, heat is lost from the land and sea also. The water in sea has a larger specific heat, so it loses temperature very slowly than land. Then the hot air above sea rises. The cooler air from the land moves towards the sea as land breeze. And the sea breeze and land breeze already we learned. No, in the examination they will ask you, how do you appreciate the role of specific heat of water in stabilizing the atmosphere? Then you have to combine these two applications and you have to write down. And we shall see the other important application, ocean currents. Due to high specific heat of water, they absorb large amount of heat at the equator without appreciable rise in temperature. So oceans moderate the surrounding temperature near the equator. Ocean water transports the heat away from the equator to the north and south poles. Already we discussed about what is specific heat and what are the units of specific heat and what are the applications of specific heat. Now I want to give you the questioning pattern. How they will ask you in the examination. I will give you some questions what they may come in the public examination. What is specific heat? What are the units of specific heat? Why specific heat is different for different substances? A samosa appears to be cool outside, but it is hot when we eat it. Why? Watermelon brought out from the refrigerator retains its coolness for a longer time than any other fruit. Why? Why copper is used for the bottom coating of cooking vessels? How do you appreciate the role of higher specific heat of water in stabilizing the atmosphere? Children, already we discussed about what is specific heat and what are the units of specific heat and what are the applications of specific heat. In the examination, they will ask you some more applications of specific heat also. Then you have to remember those 2 points. The low specific heat materials will absorb or loses temperature very quickly, and the substances which are having high specific heat, they will lose or gain the temperature very slowly. In the examination, they will ask you what is a specific heat, what are the units of specific heat, and some more applications of specific heat also. If they asked you like that, just remember these 2 points and just try to answer. All the best.